Today, I will be talking about mRNA processing. Per the central dogma, DNA is transcribed by RNA polymerase into pre-mRNA, followed by processing of pre-mRNA into mature mRNA. Mature mRNA is then translated into proteins. However, I will be focusing on the co-transcriptional processing of pre-mRNA. During transcription, the 5' end of the pre-mRNA is capped with 7-methylguanosine. Splicing occurs as well as the addition of poly-A tail to the 3' end. Typically, the 5' cap interacts with proteins such as the cap binding proteins and some translation initiation factors to shield the cap from degradation by exonucleases. It is important to note that prior to polyadenylation, a series of events take place, and I will be talking about those events shortly. The core polyadenylation proteins consist of cleavage and polyadenylation specificity factor, CPSF, cleavage stimulatory factor, CSTF, cleavage factor 1 and 2, CF1 and 2, and the poly-A polymerase. Here we see that RNA polymerase 2C terminal domain serves as an assembly surface for the processing factors. CPSF and CSTF bind to the poly-A signal and U or GU rich region respectively, where binding of CPSF facilitates cleavage of the mRNA about 10 to 30 nucleotides downstream of its binding site. Upon cleavage, an enzyme called polyadenylate polymerase PAP comes in to synthesize a long chain of adenines on the upstream cleavage fragment to make a poly-A tail in what is called polyadenylation of mRNA tail, whereas the downstream 3' fragment is degraded. Additionally, polyadenylate binding proteins bind to the poly-A tail to prevent degradation by exonucleases. I believe we have learned a lot about pre-mRNA processing. Thank you very much for your time and attention. See you another time. Bye.